Well, all right, exercise class, welcome to the last recorded lecture for exercise physiology this semester. So we were able to have the synchronous class early for the obesity stuff, so we've gotten up right to about this part in the notes, and each of you teams were able to talk about some of the other related factors to obesity up until this part right here. So we will go ahead and finish up the rest of the notes here, and then that'll be it. So let's talk about some of the physiology of obesity here. A lot of the other stuff was more kind of epidemiology and responses to exercise and things like that. But let's talk a little bit about the physiology side of things. So obesity is really known as an inflammatory disease, okay? And one of the hypotheses as to why it is that way is kind of explained here in the slide. So when we think of a blood vessel here, think of blood passing through. We've got some fat cells over here outside of the blood vessel. Okay, obviously these fat cells, just like any cell, need to get oxygen, right? One of the problems with fat cells is the way that they grow. They don't typically divide. We'll talk about that in a second, but they can divide sometimes and get more fat cells. But a lot of the growth in fat cells is just hypertrophy instead of hyperplasia, so the fat cells get large. And the thing with fat cells is their nuclei are pushed all the way to one side of the cell, okay? So as that fat cell gets bigger and bigger and bigger, what happens is the nucleus can sometimes get pushed quite a ways away from the blood vessel that's closest to it, okay? So as this fat cell enlarges, the nucleus is pushed further away from the supply of oxygen. And what happens there is those fat cells start sending out a call for help, pretty much, because they're not getting enough oxygen. They're going into a state of hypoxia, okay? So they're going into a state of hypoxia because they don't have enough oxygen. So they start sending out MCP1. And what that does is that's similar to some of the proteins we talked about that the endothelial cells express to call in the immune system. Okay, some of those cellular adhesion molecules. Okay, so what these do is they call in monocytes, and those monocytes, as we talked about before, turn into macrophages, and that leads to inflammation as well as tissue damage. Okay, so we get these macrophages building up in here. Okay, so when we get local inflammation with our fat cells, this can eventually lead to systemic inflammation. And some of the proof for that is that we see that people with obesity tend to have higher levels of CRP, C-reactive protein, which is a marker of inflammation, and they also have higher levels of TNF-alpha, which is another marker of systemic inflammation. So we see that in obese patients. Okay, so if obesity leads to inflammation, then we know that the two other diseases we just talked about in atherosclerosis and type 2 diabetes, we know those are connected to inflammation too, right? So inflammation leads to insulin resistance in our cells. That leads to type 2 diabetes. We also know that inflammation leads to cardiovascular disease. That's not even on the slide, but that's a very direct link. And then excess glucose in the blood that happens with type 2 diabetes obviously leads to atherosclerosis. We talked about that some, but that hardens blood vessels, leads to some of the damage on endothelial cells. And so we have this direct connection between cardiovascular disease and type 2 diabetes with obesity. Okay, so just a little bit about kind of the etiology of obesity, and back to this idea of fat cell size versus fat cell number, okay? And so when somebody gains weight and gains fat, the question is, do they do that by getting more fat cells or their fat cells that they currently have getting bigger, okay? And that would be known as either hyperplastic obesity, which means more fat cells, or hypertrophic obesity, which means larger fat cells, okay? And so when we look at when we actually do biopsies of people who have obesity versus people who are not obese, we look at lipid per fat cell. So this is a measure of fat cell size. We see that obese people have much larger fat cells. Okay, so that would be a case for hypertrophic obesity. Okay, but then we see on this next slide that we also see a big difference in cell number too, right? We see many more fat cells in obese people, okay? So we see both, right? So we see both hypertrophic obesity and hyperplastic obesity. And usually in people who are obese, they have more fat cells and they have larger fat cells. Okay, so they're not really there's not really a big difference there as far as when somebody's obese, they're going to have both large cells and many cells. Okay, but there is something to be said for obesity that happens during key times in life. So let's think about when you're a kid. Okay, and this is one big reason why childhood obesity is so dangerous, is because when you're growing, your whole body's growing. If you're gaining a lot of fat during that period of time, then what can happen is that's when you're likely to have hyperplastic obesity. Okay, so fat cells don't divide in number very often, but they do increase in number during certain periods of growth. So it could be during menopause, during puberty, during childhood, maybe possibly during pregnancy. Some other times when the body is doing a lot of growth, that might stimulate fat cells to divide, and that could lead to hyperplastic obesity. But the rest of the time when somebody gains weight throughout life, most of the time it's more going to look like hypertrophic obesity, and those cells are going to get large. So which type is changeable? The only type that's changeable is hypertrophic. Okay. When we lose weight, we shrink fat cells. We don't get rid of fat cells. The only way to get rid of fat cells is through liposuction. Okay. And so obviously that's not that's a very invasive method to get rid of fat. Okay. So when we typically lose weight, all we're doing is shrinking those fat cells down. Okay, so the problem is if you're gaining weight during these kind of susceptible time periods, when you can add fat cell numbers, every single one of those new fat cells that is formed is now going to want to be a certain size. Okay, and this kind of gets us to what's known as the set point theory, is that all of your fat cells kind of want to be a certain size. And what happens when we try to shrink those down and lose weight, we can do that for a little bit, but when those fat cells get too small, they start releasing all kinds of hormones that do all kinds of things. It slows down your metabolism. It increases your hunger, makes you sit more versus walk and walk less. So lots of things like that. Your fat cells are somewhat responsible for those things in a lot of people. Okay, and so there's a problem there. So if we're adding number of fat cells, then we got more fat cells that want to be a certain size, and it kind of increases your set point of weight that your body's trying to get back to with weight loss. Okay, so can you do lasting damage to your body by gaining weight? That would be in the case of the hyperplastic obesity. Okay, so as I just said, when we lose weight, what happens to fat cells? They shrink. Okay, and so we go. This is a great example here. Somebody with a body mass of 149 kilos. They got 75 billion fat cells, 0.9 micrograms of fat per cell, or size of each cell. Okay, they lose some weight, get down to 103 kilos, still 75 billion fat cells, just smaller fat cells. They lose some more weight, get down to 75 kilos, still the same number of fat cells, just less per cell. So that's what it looks like. Fat cells are shrinking. So does this affect set point? Well, there's some debate on this. Okay, so most people that lose weight, as we kind of already talked about, most people that lose weight with either diet or exercise program, if you look at them about 2 years from that time of that weight loss, most of them have gained it back, unfortunately. Okay, we don't have a good way right now to cause weight loss and make that weight loss sustainable so it doesn't go away. And the reason for that is most likely the set point. Because when we get these fat cells this tiny little size, they're not happy. They're changing your metabolism. They're causing you to eat. They're causing you to move less. And eventually that catches up with you. And then you start gaining that weight back. Okay. But there are some people who lose weight and keep it off, right? So those people most likely have somehow effectively changed their set point. But the vast majority of people are not successful in doing that. And so that's where the set point theory kind of resides. Okay, so a little bit more about weight loss. There's all kinds of different ways out there that people will tell you this is the best way to lose weight, right? Lately, it's been the low carb diets, right? The keto diet, all these different things, right? Back when I was a kid, and back in the 90s, low fat was the big thing. Fat was the enemy. Everybody said fat was the worst part of food. Don't eat fat, low fat, no fat. All that was the way to do it. Okay, but now fat's okay, and carbs are the way to do it. Right? So get rid of carbs. Carbs are the enemy. They're destroying us. They're causing inflammation. They're causing weight gain. And so, bottom line is, if anybody ever tells you to get rid of one of the three main macronutrients, and that's their suggestion for a diet, just plug your ears and walk away, okay? Because that's not, our body is designed to take in all three: fat, carbohydrates, and protein, okay? So if somebody is trying to villainize one of those three macronutrients, then stop listening, because they don't know what they're talking about. Okay, so that's one of my soapboxes. So hopefully you can think about that and check that out a little bit for yourself. Okay, what about a low-calorie diet? Right, so low-calorie diet is probably the best way to lose weight as far as dieting, or as far as a lifestyle intervention goes. Okay, and the bottom line is just getting less calories into your body than you are expending. Okay, so an intake has to be less than the output of calories. Okay, so we need to be in a negative caloric balance to lose weight, right? Exercise can help us do that, but as we saw with some of the studies that we talked about before, exercise is not very effective with major weight loss and with long-term weight loss. It seems to be good for helping us maintain weight. It's one of the key factors that helps us maintain weight loss that's already happened. Okay, but looking at exercise alone as your means to lose weight is not an effective way to lose a lot of weight. Negative caloric balance, as I said, those two things are tightly linked, and that's probably the best way to do it. Okay, there's a lot more we can talk about with this, but that's kind of just a brief thing. One of the problems with people who are constantly dieting and trying these new diets, losing weight, gaining it back, losing weight, gaining it back, that's called yo-yo dieting, right? You're going up and down like the yo-yo does, okay? Problem with that is there's pretty solid evidence to show that that's really negative, negative for your health, okay? That leads to high blood pressure, that can lead to atherosclerosis, that can lead to kidney problems, it can lead to all kinds of problems, all kinds of metabolic problems, all because your weight is shifting up and down constantly with yo-yo dieting. So there's a major problem there with people who are always trying to lose weight. They may be doing more damage to their body than they are good because of yo-yo dieting. Okay, and one thing I want to just make a point up here to talk about is some of these classic studies by Jackie A. and colleagues back from the early 90s. And what they did is these were overfeeding studies. And so they took people, had them on a maintenance diet for a few days. Here, okay, and that's this part. Kind of got them right at a caloric balance. Okay, they were getting in the same amount that they were expending. Okay, and then from there they started overfeeding them by a lot of calories. Okay, a lot of extra grams. And this graph shows you the lipid intake versus lipid storage or lipid utilization. Okay, so this is lipid utilization during the maintenance period. This is lipid intake. You can see that they're utilizing or burning about the same amount of lipids that they're taking in. So they're in that maintenance phase. And then we go into overfeeding. So now all of a sudden they're taking in 100 grams more fat per day. Okay, and what do we see when that happens? That intake goes up, but the utilization of the burning of fat actually goes down. Now, wouldn't we maybe hope for the opposite, right? If we eat more fat, we burn more fat. Okay, so that's the fat one. Now, this next slide shows you the carbohydrate one. Same thing. We're in a maintenance phase. It's the same study. They didn't just overfeed them with fat. They overfed them with fat, carbohydrates, and protein. And so when they started taking in a lot more carbohydrates, they added 150 grams of carbohydrates per day. Look what happens to their usage of carbohydrates. It goes up with it. It goes up to the point of matching it. Okay, so all of that extra carbohydrate they were eating, it got utilized. It got put into liver and muscle. It got burnt. Okay, and so that was the case with carbohydrates. But the problem is their energy expenditure wasn't changing. So if their utilization of carbs went up by that much, by by a couple hundred grams per day, then that means they didn't need to burn as much fat, right? So if they don't need to burn as much fat, then their fat utilization has to go down. And what happens to that extra fat? It all gets stored, right? The body loves having extra fat, and it stores all of the extra fat that's available. So it's not going to let go of that fat, so it's going to store it, and that's going to lead to obesity. And that's one of the most likely causes of the obesity epidemic that occurred in the between 1980 and 2000, is this excess intake of calories altogether. And some of those calories included carbohydrates and fat. If you're taking in a lot of extra carbs, then you're increasing carb utilization, and that means if you're not increasing energy expenditure, then that means you're decreasing fat utilization, and all of that fat gets stored. And so that's something to think about. If you do overeat, and it's a low-fat diet overeating, then you might be better off because you might not have as much lipid there to store. All right, guys, and that's it. We'll see you guys soon.